Hello guys, welcome back to this channel. So in this video, we'll be talking about subgraphs, building a subgraph. So what is subgraph? So subgraph is basically an open API for your smart contract, but we'll be building this subgraph on the graph protocol. So how do we go about building a subgraph? First things first, we fire up our command line or the terminal. I can do this by hitting Windows R and typing CMD and hitting enter. So right here, I'll go into my document folder. And here I'll create a directory. Let's call this token sub. I'll move into this directory I just created right now, and then I will open this with my favorite text editor. I'll be using the VS Code here. I can just do code this directory. So I can close this. So our subgraph is opened, and I'll open a new terminal because we have to run some commands here. So I'll run npm init to create an npm project, and I'll pass in the white flag, which basically means leave all fields as the default, which will be empty, and I hit enter. Close this. So we can see we have a package.json here, which is what we need. This means our project is an npm project, a node project. So what we are building here will be a subgraph for the USDT token. When building a subgraph, there are four main files you will need. The first file is the ABI, so the ABI of the contract you're trying to listen to, the event and stuff. The next file you need is the YAML file, the YAML YAML file. So this file is basically the configuration of your subgraph, where you specify the contract address, the start block, and everything. You see everything later when we get to that. Then the third file you need is the GraphQL file. This is where you specify your entities. So entities are like tables. This is where you specify your tables and the field needed. Then the fourth file you need here will be the mappings. So the mappings are your event handlers. So this is where you write your functions that handles events. In this tutorial, I'm using TypeScript. And if you don't know TypeScript, it's not really confusing. It's just JavaScript, but with types. Presently, the Graph protocol supports few networks. It supports the Avalanche network, the Phantom network. It supports Binary Smart Chain, yeah, but it doesn't support the testnet of Binary Smart Chain. Then it supports Ethereum network and all testnet of the Ethereum network. So we're using this subgraph on the Ethereum network since we are listening to the USDT token. So to begin this tutorial, we have to find the USDT address and the APIs. So now we have the USDT address, which we can copy from here. And we need the API of this token. So I can go to the contract tab. And I can go to contract. And I can see the API. The API should be down here. I can see the API, which I can copy. So to begin this whole process, I'll create a folder here, which I'll call the API. So this folder basically will house our API. And I'll create a new file here, which I'll call usdt.json. So this will be our API. And the details of this file will be what I'll copy from here, which is the API here. I'll just paste it in here. So that's basically what you need to do for the API. Next thing we'll create here will be the YAML file. So I'll create a new file. I like housing my YAML file to be on the root folder, but you can structure your project wherever way you feel like. But I like having my YAML file to be on the root folder. So I'll create a new file here outside. Create a new file. I'll name this token. For the sake of this tutorial not being too long, I will not type the whole configuration. I'll just paste it here and explain line by line what each property represents. So as you can see here, we specified the version of the subgraph. You can give it 0.1 as the initial deployment. You can be 0.1, and the description I can just call this token subgraph, or let's say USDT transfer subgraph. And the repository, I think I'll create this repository at the end of this video. And then the file. So this is the schema file. This is the we have to specify the file where our field is located. So the whole structure of the database should look like. So we'll specify the file. This file will be the token.graphql, which we are yet to create, which is also on the root folder, which we are yet to create now. Then the data source. This is where the subgraph should watch the sources. So the source is now the kind. So we can say is the Ethereum contract. So Ethereum simply means the EVM contract. So it doesn't necessarily mean the Ethereum network. So when we say Ethereum contract or the contract, we mean the EVM network blockchain. So here we specify the name. We call this transfer. This will be the name of our build. We call this transfer. Then here is the network. The network is basically what network we are deploying to. Mainnet is the Ethereum mainnet. We can specify Ropsten, we can specify BSC, we can specify Avalanche, we can specify Phantom, and the rest. Not all actually, because the graph doesn't support all networks yet, but it supports a lot of networks so far. So now we go to the source, and then we specify the address. The address is basically the contract we are trying to watch, the contract address we are trying to watch. And we can go back to this theta here. We can copy the address up here. We can go back here and paste this address. Now we have the ABI. The ABI is basically what the name of the ABI is, which we specify here as USDT. And the start block. Basically, the start block is where you tell the graph protocol exactly the block number you wish to start indexing from. So this will be the block number it starts watching from. The number here is just when the token was created. So that's the number I put in here, so I do not miss any transfers. If some blocks don't matter to you, you can specify a specific block. So from that block upwards to new blocks, it starts indexing all events or the events you specified it to index. So the mapping, and the beginning of the video I said we need a file, which is the mapping file that handles our events. So the mapping property, we specify the kind of stuff we are trying to map. So here we are specifying the kind is the Ethereum events, and the API version is 0.04. We can leave this as it is. The language we are building to will be the assembly script. Also leave this as it is. Now the file is where we specify the file that holds our event handlers. So this will be in a mapping folder, and the file will be transfer.ts. We are yet to create this also. And the entities, so these are like the tables, and the entities which we'll create in our GraphQL file. The entities, we call this transfer. Now we come to the ABIs for the event. The ABI's name is USDT, which you can find here. And we also specify the path to the ABI file, which is in the root folder, the ABI folder, and then the USDT.json, which you can find here. Next thing is the event handlers. This is where we specify the functions that handles our event. So the first here is the event, and then we specify the event we are trying to watch. This is the event we are trying to watch, the transfer events, which has this signature. So even a single mistake here will make this event not to be legit, and the graph will throw an error. So we have to write exactly the signature specified in the ABI. So if we shall copy this, we'll go to the ABI, we'll find this, let's say transfer. Okay, so we can see, let's search this. So we can see the transfer event, and we can see it has the first element, which is the from. It's indexed. The second element is also indexed, and the third element is not indexed, which is what we are specifying here, the event signature. Index first element, index second element, but a normal uint third element, third variable or argument rather. And the handler is basically where we specify the name of the function that handles this event. So we call this handle transfer. All this will be housed inside the transfer script, which we are yet to create. So next thing we need to do is to create our entities, which is a GraphQL file. We'll do this. We'll say token.graphql. Again, you can give this whatever name you intend to give this. So the GraphQL file is basically where we specify our entities, our data field and stuff. Just think of entities as the table with the feeds of the table. So here we'll do, to specify an entity, we'll do type. We can give this entity a name, so we can call this transfers or exchange. I'll just use this as exchange, and then we'll just make it to be a type of the entity class of the GraphQL. And in here we specify the feeds of the exchange table. So you can say the ID, which is of type ID. So all entities need to have an ID. So the ID is of type ID. And next here, so next thing we have to do after specifying the ID, since our event has just three parameters, the from, the to, and the amount, we can say the from will be of type string, and the to will be of type string also. So the ID will be the hash of the transaction, since it's always unique. The from will be the address, the user sending the token, and the 2 will be the user receiving the token. And what else can I add here? Okay, just for the sake, let's add block. So this will be the block number where the transaction occurred, and we can put this as an integer, which is big int. Adding a comment above any field acts as the field's explanation, is field docs. So here we will specify this. So to add a comment, you just use the # sign and then the comment. So here we will say id, or we call this transaction hash. In the block, we say this should be block number. In the from, here we say sender of token, and the 2 we can say receiver of token. Alright, so I just thought of something. We should add the amount the user is receiving, obviously. So we can add new one. This will be amount of token sent, and right here to be amount, we call this amount, and the type will also be big int. So we're done with the entity. A very simple entity here. So if you have different entities, you can keep adding new entities here. So this is a very basic entity. I mentioned we'll be using TypeScript in this tutorial, and just to set things up, we need to specify our dependencies. So at the very bottom, can do this. So the dependencies here will be using the GraphProtocol command line. So this is the command line. For the sake of this tutorial, use exactly the same version I'm using here, because other versions might have breaking changes. So use exactly the same version I'm using in this tutorial. And also we need the graph TypeScript. So this is basically the configuration we're using for our TypeScript of this project. So also use the same version I'm using here. And also we need TypeScript because we are building with TypeScript. So we need TypeScript. And then we need to create a TypeScript config. So we'll do ts config.json. I guess this is how. So here we'll specify our configuration of our TypeScript. So I'll just paste some configuration here. What I'm doing is just extending the graph TypeScript configuration. So I'm just extending the graph TypeScript configuration, and I just want to do this. This is just a basic configuration of the TypeScript. It's not really, you don't really need to understand it. All you need to know is that I'm extending the configuration of the GraphProtocol TypeScript config. That's just all you need to know here. I'll save this and go back and close this. So at this stage, we've not created our mapping yet, but at this stage, we should just install our dependencies, and I'll run yarn. I prefer using yarn, but if you're using npm, you just run npm install. But I'm using yarn, so I'll run yarn install, and I hit enter. This should install our dependencies. Okay, so our packages has been installed completely, and now we have our node modules files which has our packages. Now we need to create our mappings. I'll close this. So we'll create a new folder here. This is not compulsory, you can put this on the root, but I just like have my project structured. So here we can create the mappings folder, and in here we've already specified in our YAML file that we are housing our event handler in the mapping folder and the file name transfer.typescript ts. So in this mapping folder, we'll create a transfer.ts file. So this is where we specify our handlers. So here we'll be importing some files. There's a command we'll run which will generate these files for us, but we'll not run it right now. So this file, this exchange, is the entity we specified here. So when we run our generator, it will generate a class with this entity. So which is what we are exporting, which is what we are importing to our handler here. And the transfer is basically the event. So we are importing the entity, the exchange entity, and the transfer event here. So right here in this mapping, we'll create a function and we'll call this handle transfer. So this is the name we specified in our YAML file also. If you check up here, yeah, this is the name we specified in our YAML file. So it needs to correspond. And in the transfer here, this YAML file will take a parameter, an argument. This argument will basically be the event. So say the event, and we'll give it of type transfer. Remember, this transfer here is just the event class. So we're giving this variable event to be of type transfer. And then this function will return void. And we need this. It should be void. Right. So in here, we need to start doing our saves and like to save to the database and to fetch data from the database from here. So the first thing we need to do here is load an event. So we'll say exchange. Remember, this is the entity we gave in the GraphQL file. So exchange.load. So we're trying to load an event. And we know the event of the Ethereum network has a transaction and a hash. So since we want the hash to be the primary ID, to be the key of every row in the database, what we'll do here is the event transaction. So for a particular event, there's a transaction property to it, and then we get the hash, and we just convert this to hex, which is lowercase basically. Because IDs are case sensitive, we'll convert this to hex, which will give us the lowercase version of the hash file. And we'll load this. We'll store this in a variable. Let's call this transfer. So if this ID doesn't exist, say if transfer is null. So if transfer doesn't exist, what we want to do is transfer should be a new exchange, and the event that hash transaction dot hash dot hex. So all we are doing here is we're trying to load an event. If the event doesn't exist, because let's say it's just the first, if the event doesn't exist because this user is just sending the token and to be the first time it's calling this function, so definitely the event will not exist. If the event doesn't exist, we just check. If it doesn't exist, let me add title here. If it doesn't exist, we create a new index on the database. So in this case, this is not really necessary. We should just create a new index, because whenever this is being called, the user doesn't exist. But I just want to show this method because when you're working with a large subgraph, there are times you need to update a state and you need to check if the state already exists so you can do your update. And if it doesn't exist, you create a new data set. So that's the reason I just created this here. But setting only this directly will work perfectly for this case. Now what we have to do is, since we have the transfer, the exchange, which is this, since we have this entity here, all these fields are available to us. So here we can say transfer. Note when we call this, the ID has already been set to the hash. So we can say transfer.from should be the event.params. So these are the parameters of the event, and we get the from field, and we convert this to hex. Since this is an address, we convert this to hex to get the lowercase of this. And we do the same. I'll just duplicate this. We do the same for the 2. So 2, and also we do the same for the amount. Okay, we're missing in our graph. We specified a block, so we're missing a block. To get the block, we can just do this. Say transfer the block, which should be event.block.number. So we're getting the block number, we're assigning it to the block field of the transfer row. So after we've set all these fields, all we have to do is save it. So say transfer.save. So what this does is just saves this input to the database, which we can query later. And I think this is all we need here. Next thing we need to do is run some commands to build and deploy, because right now this generated schema and transfer, which is the event, they don't exist yet. So we need to run some commands to generate this, to generate our entities and our events, and then we need to run some commands to deploy. First, we have to create the subgraph on the Subgraph protocol. So I'll switch to my browser. And I can close this. We don't need this. I'll be deploying to the legacy protocol. The graph added the Subgraph Studio of recent, but I'll be applying to the legacy protocols. It's easier to follow in this case. Most DeFi most DeFi are on the legacy protocol because they've not migrated to the studio version. So we can do this by going to where do we do that? We can do this by going to I just go to direct link slash legacy protocol legacy explorer. So when we go to the legacy explorer, as we go to the legacy explorer, if you're not logged in, you'll be prompted to sign in. You sign in with your GitHub account, and I'm already signed in. So I'll sign in with my once you sign with your GitHub account, you'll be authenticated. And now you can see different subgraph here. We can see the Uniswap subgraph here. We can see compound. We can see lots of subgraph here. So once we create ours, so we'll go to our dashboard. So this is our access token, which we'll come back to in a bit. So we'll go to add subgraph. I'll open this in a new tab. So once we go to add subgraph, we have this input. So we can choose our image for the subgraph. I'll just leave this as it is. Then this is the subgraph name. We can call this USDT transfers. Okay, we call this USDT transfers, and we can see a link is generated for us. USDT transfers. The account is my GitHub account, so it's definitely Isaac Frank. The subtitle is compulsory, so we can just say this is a short description. We can just say indexing all USDT transfers. Here we can write so here we can write a long description. I can leave this empty, and the GitHub URL HTTPS GitHub. You can specify the GitHub URL here if your code is open source. So I'll just say since I don't know what the URL will be yet, I can just do Frankie just directly to my GitHub homepage. Maybe when I upload it can be found here, and I click on create subgraph. As you can see, the subgraph has been created for us. We can see the steps. We need to install subgraph. We need to this is just a tutorial. We can fork the hello world subgraph and we can deploy. So we've installed this, we've done all this. The part we are waiting for is the deployment part. As you can see up here, we can still see our access token here, which we'll need soon. So I'm going back to my code right now. Now the first command we need to run is the code generator command. So this is the command that generates our entity and our event for us. So we can run that. To run that, we just have to do graph. Remember, we installed graph CLI in our package.json. This is it. We installed it in our package.json, which means this module is present to us in our command line. So we run graph and we run code generate, and we have to pass in the file we are trying to generate code for. The file we are trying to generate for is the token YAML file. So say token.yaml. And this should generate the code for us. Let's wait for this. Okay, there's an error here. There's an error here. Our file doesn't exist. Okay. I don't get it. The folder name is ABI is here, but our folder here name is ABI without an S. So we can add an S here. Just call this ABIs. And we can run this again. So we can see migrations is happening and it's generating types for us. So we can go to this generated folder, and if we go back to our mapping, we can see generated schema. We can see the schema here. This is where it generates the exchange for us, which is the entity, and we can see the method, the save method. We can see the load method, all these setter and getter functions. We can see everything here. In case we want to run this generator, when we make changes, we want to run this generator in the future, so I will not have to type in this long command. I'll add this to package.json in my script. I can move this right here. I'll say code gen, and this will be graph code gen token.yaml. All right. So in the future, in case you want to run the same command, you can just do yarn or npm run then code gen. If you're using npm, just do npm run code gen. So this will just run the command for us. As you can see, it's running the command for us. We don't have to type in this long code. Okay, so that's how we generate our subgraph. Now we need to deploy. To deploy, the code for deploying is kind of long, so you just have to follow me and do this. Now we need to deploy this, and the deployment command is really long, which is why I will add this as a script. So call this deploy. So we'll say graph deploy. Now in there we specify the product. Ever since they added the studio, we have to specify the product if we are deploying to the studio or we are deploying to the legacy explorer. So in our case, we are deploying to the legacy explorer. So we'll do hosted service, I think, and then we'll specify the node. The node is basically so this is what is responsible for our deploying, and we also specify IPFS. So saying IPFS. So we're specifying the node. This will be our deployer, and for the IPFS to deploy to IPFS, which is file hosting stuff. So this will be our deployer. Next thing we need to specify here is our subgraph, the one we created on the graph protocol, which is this. So we need to specify our subgraph link, but not the full link. So our subgraph, since all links are related, just the username and the subgraph, that's what we need. So copy this and we go over here and we paste this. Now next thing we need is our access token. So we can do access. This is to authenticate that we are the right user trying to deploy, and we do access token. We specify the access token. I run this command. I'll do yarn run deploy, and since it's basically this deploy command is basically this whole thing here, I can specify my access token at the very end. So I'll copy my access token, which you can find here. I'll copy this, or in your dashboard you can find the access token. So I'll copy this and I'll go over here and I'll paste this. So let's see if this works. This subgraph.yam file is not available. Where did we import subgraph.yam? We need to specify the configuration file we're trying to use to deploy. So after specifying all these and the subgraph we are deploying to, we need to specify the file we're trying to deploy. So the file we're trying to deploy is the token.yam file. So say token.yam file. By default, it searches for the subgraph file. So if our file was named subgraph.yam, this should work. But since we're using a different name, we have to specify the file. So this is the file we're specifying here. And if you run this command, this should work now. Alright, so we can see it created a build folder for us. This is what it deploys, this build folder. Hopefully this works. Now it's deploying to the graph node, and deployment was successful. As you can see, deployment was successful, and we get our API, our WebSocket, and our HTTP API endpoints. We can get it, but by now it's not yet indexed. So if we should go back to our subgraph, if we refresh this page, yeah, we can see it was deploying. It failed. Okay, our transaction failed. Let's see. It was syncing, but it failed. I don't know why it's failing. Right, so we forgot a keyword in our event handler. So we specified that the function responsible for handling our event is our handle transfer. But in our script, we never exported this function. So there's no way for the subgraph to be able to call this function. So to fix this issue, we just need to add export here. So what this just does is export our function, which means our function will be available to the subgraph to be able to call it whenever an event occurs. Now we need to generate a new code because we've changed the source. So we can run yarn code gen. So it's just running the code gen script we have in our package.json, which is the code gen script. If you're using npm, it's npm run code gen. So once we hit enter, this will generate the code for us. Okay, so it's generated successfully. Then now we run the deploy command. This deployed the new build online. So let's see this. So every event handler has to be exported. Any event handler you create, it needs to be exported so that the graph protocol will be able to call the function. So every event handler needs to be exported. So now it's been deployed. Let's check if everything worked or is working as planned. Now refresh this. As you can see, it's syncing and there's no error. So it's syncing. If our start block was like the Genesis block, the syncing would have happened from the very beginning. But now it's syncing from the 4.9 million, and there are 13 million blocks in total. So every transaction, it's adding them. As you can see, the entities keep increasing. So these are like the rows keep increasing. So we can query this data now using this public API it gives us, or we can use the playground right here to query the data. So we can say exchanges, which is the entity we created, which is this exchange entity. And in here, we can specify the field we want to be returned. So we are specifying the ID, the block, the from, the to, and we also need the amount to be returned. And if we should query this data, we should get some data. Let's see. Now we're querying the first 5. If you can see here, we have 1 and 2. We have the third one. We have the fourth one, and we have the fifth one. So we can query as many data as we need here, but we're just querying the first 5. And so the amount is this, and it happened on this block. And there is this is the address that sent the token, and this is the address that received the token. This is the address that received the token, and this is the transaction hash. So we've created our subgraph and it's working right now. We can also filter subgraphs. So we can say something like where the block is greater than, let's see, where the block is greater than 6 million. Let's see, 6 1 2 3 1 2 3 1 2 3, and we run this. Now we don't have any data. This doesn't mean that there is no transaction happening on this particular block. It's just that our subgraph so far has synced just in the 5.3 million zone. It hasn't reached the 6 million block, so it can't get transaction for what it hasn't saved. So if we should reduce this, let's say 5 million, we should get some transaction because it synced that particular let's see, 5 million 5 1 2 3 sorry 5 million. We get some transaction because it has synced that particular block, so that block and above would be gotten for us. But if we use 6 million, let's see, we have empty transaction because so far it hasn't reached the 6 millionth block, so it can't get any data corresponding to this block here or the block greater than this. So we can filter this event. When building your dApps, you no more need to look at past events and try computing stuff. So you just use the Subgraph, the graph protocol, and create your subgraph. Then in your front end, in your dApp, you just need to be fetching data instead of having to be fetching data from the Ethereum node. You just need to be fetching data from an API, which will help you a lot and save you a lot of time when building dApp. So this is how you create your subgraph on the graph protocol. If you like this video, please hit the like button and subscribe to this channel if you haven't already. And thank you guys for watching, and I'll see you guys in future videos.